the bar goes up, and then minus mg because your weight's going downwards. Wind resistance working against you. Air resistance is kV squared per unit mass, so that'll be m kV squared, which means our force, net force, is minus mg minus kV squared. Net force is ma, and that means A is minus g minus kV squared. Okay, now what does the one come? Once the maximum height reached by the particle, maximum height will be an x value, yeah? Huh? Well, it gives us, it's not looking for it, we can use it. Okay? And it wants the value of u in terms of k. So, should I use the VDT? Or should I use m the v, sorry, v times the VDX? Which one? Why? Huh? Yeah, it's going to be a, yeah, it gives us the height, yeah? And u is the speed. So the reason being is it gives us one of the limits. The limit it gives us is a distance limit, which indicates we should use x. U is its velocity, which indicates v, the VDX, not the VDT. No mention of time. Many people went for the VDT. Good. Okay, guys. So v times the VDX ends up to minus g minus kv squared. Now, my gut feeling is to leave those minuses behind. Yeah. So to make my life easy, I'd almost factorize that out. I'm not saying that you guys have to, but I'd be much happier using pluses. I'm going to send up the dx this way, so it's going to be minus 1 dx, and on the other side it's going to be v g kv squared. You don't have to. Who did that, or he just kept all his minuses? And we keep all his minuses. Do you want me to do all his minuses? Let's go with that. Just wanted to remove the minus 1 out, just makes it easier. V, and then we have our limits. Now, what I'm thinking here is the derivative of the bottom one is similar to the top one. Like this bottom one's an issue, isn't it? Like I don't have an inverse tan. I can't use ln. I'm stuck. Okay. Or can I use ln? Yeah. Yeah, we always use u sub. So what we're going to do is a u sub like this. U equals g plus kv squared. Then we're going to differentiate it. U to v is, oh wait a second, that'll do it. 2v k. Then bring 1 over 2k du equals v to v. Ever see that? Goes everybody happy enough for that? 1 over 2k du is the same as v to v. Yeah? Now, we go back up. Everybody see that v to v, which is in this section here, in green? We're going to sub that out. What are we going to sub it out for? 1 over 2k du. That's a constant. And what about the yellow part? 1 over u. Now let's put in some limits. What are we thinking for limits? To start a rest? Nope. Starts at u, so that's going to be a u there and a 0 there, yeah? I'm going to keep this as x for the time being, but we all know that x is what, guys? What's the height it reaches? ln4 over 2k. I'm going to have that in my back pocket ready to go in case I need it, okay? And what's its velocity at the greatest height? 0. So when you reach your greatest height, your height is 0. So that explains that limit. Let's have at it. 1 at 2k is a constant. It goes straight through. The integratable part is the 1 over u, which is ln u. Now, see those limits there? They're a mistake currently. Why are they currently a mistake? That's not for u, it's for v. So I'm going to quickly back out of that. And what I'm going to change this u into? G plus kb squared. And I'm going to put them back in, 0 and u respectively. And on this other side, I'm going to have minus 1x from x to 0. So we close that. Okay. And we get minus 1x. And we get 1 over 2k ln kb squared turns to just g, doesn't it? Yeah. And then the next one is minus 1 over 2k ln one over 2k ln g plus kb squared. Everybody happy enough with that? See that 2k? I'm not happy about that, so here's what I'm going to do for the time being. I'm going to put 2k here and a 2k here. And what does that effectively do to all the 2k's? Gone. Don't want to deal with them at all. Okay, so it's going to be minus 2kx. Okay, what's it asking for again? Does it want to find out the v? It wants to find out what u is equal to, doesn't it? Oh yeah, that's a u, not a v. Thank you. Thank you. Might be a good time to put that x in now, won't it? What's the x value? We had it stored up here. ln4 over 2k. So minus 2k ln4 ln4 over 2k. So what does that turn that into? Minus ln4. Okay. All that turns into minus ln4, which we're pretty happy about. No war here. And this other side is going to be ln g plus ku squared. Now, do you know what I'm going to do with that? Minus 1 on the outside. Anybody have any idea what I'm going to do with that? 4 to the power minus 1. ln a quarter. And now, what can I say about the two things in the brackets now? The two things in the brackets are there. Same thing. Not this so long. Is this still question? Is this still question 13? Okay. Lovely. Still question 13. All right, I'll get there now in a minute. So it's g over g plus ku squared equals 1 quarter. 4g equals g plus ku squared. ku squared equals 3g. U squared equals 3g over k. And then we square root it, and we have the right answer. U is in fact the square root of 3g over k. Now, to be honest, that feels like I've been involved. Now, part 2, guys. We go back up here. Now, what does it say this time? Please find the value of k if the greatest time, if the time to reach the greatest height is pi over 3. So pi over 3, yeah? So, time greatest height. Okay. Could I change this v dv dx into the v dt? All right. There's nothing disqualifying that so far. And exactly. Usually sleep at this time of the day. Now, I'm going to do that same trick I did last time. I'm just not messing around with those minuses. Those minuses can be gone. I can have a look at it in a minute. Yeah, I'll just lock this one out. Like, we didn't really isolate x in the last one, or we didn't really isolate b, did we? What were we given? We didn't isolate x. So we have to isolate b in terms of x. There's still no time involved there. I didn't isolate it, so I wouldn't bother. The other reason why I'm leaning this way is, do you see the pi over 3? Screaming trigonometry at me. So that's why I'm just a little bit wary. Okay, this is actually quite tough. This is very tough, this one. Are you ready? So, minus 1 to t, to v, exactly. Would everybody be happy with that so far? Okay, now, do you know what I'm thinking? I'm thinking about doing something different than the book for this, because I never would have done it the way they're doing it. So I'm going to try it my own way now. Okay, you ready? So here's what I'm thinking. What is the isn't it 1 over a squared plus x squared? Would you agree with that? A squared plus x squared? That's usually what we're doing, isn't it? And then dx would be 1 over a tan inverse x over a. You cool with that? Now, in the a squared's position is what? What's in the a squared's position? What? G. Would we just say that a equals root g? That be okay? Then what's in the x squared's position? What do you think? kb squared, yeah? So what do we think there? Well, yeah. It's not the way the book has it done, but we're going to run it like this. I think we do it like that. Now, what do we think we're going to, how do we think we're going to integrate this now? All right. Okay. 0 to what, guys? T. 0 to 5/3. Have no, I don't want to isolate this. I just want to get it done. Yeah? And then on the other side, what we're thinking, greatest height means your speed is 0 at the top. And what did we start off with, u value was? I think we got u, didn't we? What was u again? We just did it a minute ago. Root 3g over k. Are you ready? I'm running out of time. Okay, lock in. Okay. 1 over a, 1 over root g, tan inverse x over a, which is root k times v over a again, isn't it? Now, pretty sure I'm forgetting something here. I think I have to differentiate that. I'll just keep a question mark there in mind. Okay, what about the other side, guys? Minus t from 5/3 to 0. All right. So, suppose as you do this, you're going to get minus pi/3. Okay, and this one here is when you're inversing this, you also have to, it's 1 over g tan inverse kv over root g. I suppose what we should have done there was a substitution. This, I made this part way too difficult, okay? So we're going to go back to the top again. And we're just going to look at this part here. I'm not going to go direct, that was just too difficult. So we're going to re-look at this 1 over kv squared g. I'm going to divide all of this by g. So put g here and g here. And what we can get is it's 1 over, say, what is it? Divide them both by g. And it's 1 kv squared over g. And then what we can use is a substitution. I'll use a substitution that y. So I'm looking to set up the 1 plus y squared, the y here. So I want to integrate that rather than integrating this. So what I'm going to say is let y squared equal kv squared over g. And then in turn, when I square root the other side, it's going to be y equals root k over g v. Okay? And then remember, this is a constant, by the way. This is a constant. So when I differentiate it to get the y to v, this is going to be root k by root g. And then obviously you can bring up the, I can turn that upside down then. And I can get it's root g over root k. The y equals the v. So essentially this part here has been changed with y squared, and this part here, the v, has changed with the y, but the y also comes with a root g and root k component, like so. And now this is easy. Now I can just tan inverse. It'd be root g over root k tan inverse y, okay, and equals pi/3. And then I need to look back at what my y is. My y was root 3 root k, so root g root k tan inverse tan inverse root k root over knew what the v limits were earlier. What were the v limits? 0 and root 3g over k. And this is quite difficult here. So what happens next is the following. We go for root g over root k. You know, tan inverse 0, the first limit is gone, because when we put in a 0, the whole thing turns to 0. So I'm not bothered about that. I'm focusing on the second limit here. So it's going to be tan inverse root k over root g, which is basically this part here. And then my v, tan inverse root k over root g. And then I'm going to sub in this part, which is root k on the bottom. I'm going to break up the root 3g into root 3 root g. So it's root 3 root g. The root g's cancel. The root k's cancel. And now my answer is looking like root g root k tan inverse root 3. That's all minus because it's the second limit. It's the lower limit. That equals minus pi over 3. If you tan inverse root 3, you'll get pi over 3. So that's gone there. The minuses cancel each other out. The pi over 3 cancel each other out. And then you're basically about to get a... Oh, God. G's cancel each other out. You get root g over root k. I think I made a mistake here somewhere. Yeah, so when I divided dot with these by g, yeah, I forgot that there was a 1 over g to balance that out. Can't just divide without giving it back again. So there's also a 1 over g in this whole system. And then what happens next is the g cancels out with the root g, so you get 1 over root g root k equals 1. And then finally I get root k equals 1 over root g, square both of them, I get k equals 1 over g.